In today's class, we discuss about normal distribution. The continuous probability distribution having the probability density function f of x given by f of x is equal to 1 by sigma of square root of 2 pi e raised to minus x minus mu square whole square divided by 2 sigma square, where x lies between plus infinity to minus infinity and mu lies between plus infinity to minus infinity, and as that sigma is greater than 0, which is called as normal distribution. So it is clear that f of x is greater than or equal to 0 and minus infinity to plus infinity, integral over f of x minus infinity to plus infinity x is, that is given this integral is equal to 1. So since it satisfies both the conditions, we call it as a function as a probability density function. So note, in normal distribution it can be derived as a limiting case of the binomial distribution when n is large, neither p nor q is very small. We can derive f of x as n tends to infinity, so that p and q both are equal to 1 by 2. Mean and standard deviation for normal distribution. Mean mu is given by integral minus infinity to plus infinity x into f of x dx. So when you substitute your f of x and go on solving, we will get a mean mu as mu only. So means what? Mean for the normal distribution is equal to the mean of the given distribution itself. So variance sigma square is again its integral over minus infinity to plus infinity x minus mu whole square f of x dx. So this is f of x dx, which is given by 1 by root pi to 1 by square root of 2 pi integral over minus infinity plus infinity over f of x dx. We have to substitute x minus mu whole square into f of x. So again simplifying substitution method and simplifying, we will get variance as a sigma square. Here also this variance and also standard deviation for the normal distribution is equal to the given distribution. Now the graph of the probability function, this given probability function f of x is this bell shaped. As in the figure. So it is like this. In the figure, just see here, it is a curve symmetrical about line x is equal to mu and is called as normal probability curve. The shape of the curve is as follows. Here this x is equal to mu. It divides the total area under the curve, which is equal to 1. Means what? Which divides this curve into two equal parts, such that both right side and left side and right side of the line is equal. That is, since the function that always equal to 1, so x and mu both are equal to 0.5 here, because it divides the line curve in two equal parts. So next comes standard normal distribution. Standard normal distribution means what? Before in the normal distribution we discussed limits will be x and this mu lies between minus infinity and plus infinity. And here for the normal standard distribution, x lies between the interval, that is a and b. Here we took a and b. So it is given by probability of the x which lies between a and b is integral over a to b f of x dx. So in the case of normal distribution, we had probability of this x is given by 1 by sigma square root of 2 pi integral over a to b e raised to x minus mu whole square by 2 sigma square dx. That equation represents the area under the standard normal curve from z equal to 0 to Z. That curve is shown in figure. That is like this. In the curve, that whatever shaded portion is we are looking, that represents the area under the curve, that is phi of z. That area is denoted by a of z, other phi of z. The area on either side of the z, that is z equal to 0, is both the side it will be 0.5. For this we will get a standard positive values for z. There is a table. To solve the problem we use that table and we'll solve the examples. So before going to examples, we will require some of the important properties or equations. First one, integral minus infinity to plus infinity. Phi of z dz is always equal to 1. If you divide this integral into parts, that is integral from minus infinity to 0 phi of z is equal to 0 to infinity phi of z dz, both are equal to 1 by 2, that is 0.5. These results are in equivalent form. We can write it as follows. Probability of z between minus infinity to plus infinity is always equal to 1. Probability of z between minus infinity to 0 is 1 by 2. Probability of z between 0 to plus infinity, or probability greater than z equal to 0, z is greater than equal to 0, is 1 by 2. Also, probability of z between minus infinity to z1 is always equal to sum of two probabilities, that is z between minus infinity to 0 and z between 0 to z1. This is nothing but probability of z less than z1 is always equal to 0.5 plus phi of z1. Also, probability of z greater than z2 is probability of z greater than equal to 0 minus probability of z lies between 0 to z2. That is nothing but probability of z greater than z2 is 0.5 minus phi of z2. So we use these to solve the example, and standard table is the given. Just while solving the problems on normal distribution, we have to keep this table and we need to write the respective values of the table. So along this vertical axis you are having values of z from 0.0 to 3.9, and horizontally you are getting numbers from 0 to 9. So whenever we solve the examples, keep this table beside and write the respective values for 5. So in the next class we will solve examples on normal distribution. Thank you.